Precalculus, page 384, numbers 12 through 34 even. And let's dive in. Please, in some of my classes I'm having an issue with folks not using the correct subject line on your emails. Please tell me the subject and then the page number of the assignment. You do not need to put your name in here, just subject and page number in that order, please. Makes it a whole lot easier for me to sort my emails and put them into folders. So thank you for doing that. And excuse me, we move on. A little congested here. Number 12, cosine of 420. For the cosine of 420, here's the concept. Remember, the point is that sine and cosine and tangent, and of course the reciprocals, all the trig functions, are periodic functions. They repeat themselves over and over and over again. For cosine and sine, they repeat themselves every 2 pi. So we can, from that 420, we can take out 2 pi, or 360. So if we take out 360, what are we left with? We're left with 60. So this is actually the cosine of 60 degrees. And let's see, the cosine of 60 degrees turns out to be equal to 1/2. We are done. I'm not going to use this video to review the process of finding the cosine of 60. You can go back to other videos to review that process. Number 14, for the sine of 390. Again, you can take out any multiples of 360. So we'll take out 360. This becomes equivalent to the sine of just 30. And the sine of 30 degrees, that is. The sine of 30 degrees is 1/2. You're done. Number 16. We want the secant of 540. The secant of 540. Again, these are periodic functions. Secant repeats itself every 360 degrees. So I'm going to take out all multiples of 360. Well, I can take out one 360 from this, and if I do that, I'm left with 180. So this boils down to the secant of 180 degrees. And for the secant of 180, just a reminder of how you can handle that if you like SOHCAHTOA. Make yourself a little 0-degree triangle here, and that side is 0. Secant is the reciprocal of what? Yes, secant is a reciprocal of cosine. Cosine would be adjacent, which is -1, over hypotenuse, which is +1. So the secant is -1. The cosine is -1, and the reciprocal of cosine, secant, is also -1. And we go on to number 18. Wow, we're flying through these. Number 18 says, secant of 420. Secant of 420. Again, to find the cotangent and the secant and the cosecant, do sine, cosine, and tangent first and do their reciprocals. All right, so for secant of 420, again, secant being a periodic function, we can take out any multiples of 360. So we take out one 360 from this, and we're left with 60. This becomes the secant of 60 degrees. And the secant of 60 degrees, let's see, lost my place here, number 18, turns out to be precisely equal to 2. And we move on to the next one, which is number 20. Now we move into radians. Sine of 9 pi over 4. 9 pi over 4. Well, sine being a periodic function, you can take out any multiples of 2 pi. So we can take out of this 9/4 pi, we can take out 8/4 pi, better known as 2 pi. So if we take 8/4 pi out of this and chuck it in the trash, we're left with what? Taking out 8/4 pi, 2 pi, we're left with 1/4 pi. So then we find the sine of 1/4 pi, which, in case you care, is the sine of 45 degrees. And you go to your unit circle, 45 degrees. You remember, of course, that this gives you square root of 2 over 2 here and square root of 2 over 2 there. Sine is opposite over hypotenuse, so the result is going to be, this is not a true equation. The sine of 9 pi over 4 is equal to the sine of pi over 4, which is equal to square root of 2 over 2. Confirming that I didn't mess it up. Yep, that is correct. Number 22, we have cosecant of 9 pi over 2. Cosecant of 9 pi over 2. So the big question is, what does this boil down to? We toss out any multiples of 2 pi. Well, this happens to, we can toss out a total of 8 pi here. If we take 8 halves pi. If we take out 8 halves pi, better known as 4 pi, if I take 4 pi out of here, if I take 8 halves pi out of here, I'm left with 1 half pi. This becomes cosecant of pi over 2. In case someone's lost on that, just another way of looking at this, as I believe I showed you either in the last video or in class, I don't even remember now, probably in the last video, we can think of this as being, well, what's 9 divided by 2? 4.5. This is 4.5 pi, right? 9 halves, 4.5. Well, I can toss out any multiples of 2 pi. So I can toss out 4 pi. If I toss out 4 pi, I'm left with a half pi. There it is. And the cosecant of 1/2 pi, which happens to be, by the way, the cosecant of 90 degrees. Ooh, let's think about that for a moment. I'm not certain we've ever seen one quite like this. We've dealt with the little miniature triangles here and here, but I'm not sure we've ever dealt with one for a 90-degree angle like that. Oops, lost it all. So I'm going to create myself a little miniature triangle here, understanding that in reality, if this were 90 degrees, this side here, the adjacent side, would be 0. And this is 1, and this is 1. And that settles that. Cosecant, reciprocal of sine. Sine being opposite over hypotenuse. The opposite is actually 0. I'm sorry, wrong. From this angle. The opposite is actually 1. The hypotenuse, yes, is 1. You know, this little miniature triangle is confusing me too. The opposite of 1, the hypotenuse is 1, so cosecant, sine is 1, so the cosecant is also 1. The important thing now is not figuring out what these values are, because that's old stuff. The important thing is understanding that you toss out 4 pi, or 8 halves pi, out of the 9 halves pi. So that one is 1. Okay, and number 24. 24, same stuff. We're looking at cotangent. Cotangent is a little bit different. Cotangent of 17 pi over 4. What makes cotangent different is you don't toss out multiples of 2 pi. With tangent and with cotangent, those are periodic, yes, but they repeat every pi, or they repeat every 180 degrees. So you toss out any multiples of 1 pi. So if we toss out here, this would be 16 fourths pi plus 1/4 pi. We can toss out the entire 16 fourths pi, the entire 4 pi. We're going to toss out an entire 4 pi out of this thing, 16 fourths pi. I can toss out all pi's. If I had 5 pi or 3 pi, I could just toss them out. I'm left with 1/4 pi. It's equal to the cotangent of 1/4 pi after I toss out my 16 fourths pi. And the cotangent of pi over 4 being the reciprocal of tangent of pi over 4 ends up being, final result is 1. It's equal to 1. That was number 24, right? Yes. 26. 26 is the secant of 25 pi over 6. Well, again, secant being the reciprocal of cosine means you can toss out any multiples of 2 pi this time. Well, 25/6 is equal to 4 and 1/6. So we can toss out 4 pi out of this. If I toss out 4 pi, I'm left with 1/6 pi. I'm tossing out 24/6 pi, leaving me with the secant of 1/6 pi. And of course, if you prefer degrees, that's the secant of 30 degrees. And the secant of 30 degrees turns out to be 2 square root of 3 over 3 equals 2 square root of 3 over 3. It's of course the reciprocal of cosine, and cosine would have been, what is cosine? Do I have it written down here? I don't want to think it through again, trying to save some time here. Cosine is square root of 3 over 2. Yeah, cosine would be square root of 3 over 2. So we want secant, which is the reciprocal of that, which is 2 over square root of 3. Then we multiply by square root of 3 over square root of 3, thus getting 2 square root of 3 over 3. Because it's the reciprocal of sine, or I'm sorry, cosine, and that's the cosine of 30. We finished that so quickly, I'm tempted to review once again why the cosine of 30 is that. So let's take a quick look at the unit circle. We've got 30 degrees here, that's 1, that's 1/2, that's square root of 3 over 2. And so cosine being, so katoa, adjacent over hypotenuse, is square root of 3 over 2 over 1. There it is. But we didn't want cosine, we wanted secant, so we flip this guy upside down. And when we do that, we have to multiply by square root of 3 over square root of 3. And again, we get this. All right, that brings us to something easier, I think, and that is number 28. We go to our unit circle, and we make use of all students take chemistry. All students take chemistry. A for all, S for sine, T for tangent, C for, come on, I can do this, cosine. And now, we look at number 28. It says that the sine of my mystery angle is less than 0. It says that the cosine of my mystery angle is greater than 0. This says the sine's going to be negative. This says the cosine's got to be positive. So our question is, in which quadrant will both of these things be true? Well, where is sine negative? Here, they're all positive. Here, sine is positive. Sine will be negative here and here. So our result could be in quadrant 3 or quadrant 4. But wait just a moment. We're also told that the cosine has to be positive. Well, where is cosine positive? Cosine is positive here and here. Well, the only place that satisfies both of those conditions would be this quadrant. So we're talking quadrant 4. Remember, the quadrants are always listed with Roman numerals. So we are talking quadrant 4. Let's do that again with number 30. With number 30, we have, again, we'll do this, this, this. All students take chemistry. And to save myself a little bit of trouble on the last two problems, let me lock this. Okay, now, so for number 30? We're told that cosine of my mystery angle is positive. We're told that tangent of my mystery angle is also positive. All right, so where is cosine positive? They're all positive here. Let's change, oh, I did already. They're all positive here, and cosine is also positive here. So my mystery angle has to be here or here. But we're also told the tangent is also positive. Well, where is tangent positive? Tangent is positive here and here. Well, the only place where those two requirements overlap is here. We must be in the first quadrant. Done. Number 32. Number 32, we are told that the cosine of my mystery angle is negative. We're told that the tangent of my mystery angle is positive. So where is cosine negative? Certainly not there and certainly not there. Cosine is negative here and here. But also tangent must be positive. Where is tangent positive? Here and here. Where is the only quadrant that satisfies both conditions? Right there. We're talking quadrant 3. Done? And we move on to the last problem of this assignment. Page 34. Number 34. Page 34. Number 34. 34 says, it's hard for them to make these hard. They found a way. Cosecant of theta is greater than 0, and cosine of theta is less than 0. All right, cosecant. What are we to do with that? Well, cosecant follows the same rules as its reciprocal. Sine, cosine, tangent, cotangent, secant, cosecant, reciprocals. So the sine rule of cosecant matches the sine rule of sine. So we could just as well change that to say sine, if it makes you feel better. So where is sine, or where is cosecant positive? Sine is positive, cosecant is positive here and here. Where is cosine negative? Cosine is negative, not here, not there, here or here. The only quadrant that satisfies both requirements would be quadrant 2. Quadrant 2. And we're done checking page 384. Now, I have not prepared to go on to the next part of this chapter, or this section. I may do that by the end of the day, or I may not. Just watch your emails. If I do something new, it'll be by 3 o'clock. It's already 1:11. I don't think I'm going to have time to squeeze that in. But watch your email. See if there's a new assignment for the new part of the chapter, of the section. Otherwise, we're done with this. Is there anything else I can throw in here for some extra practice? Well, those are kind of fun. Yeah, let me throw a little bit more at you here, because this stuff is actually kind of cool. Hopefully I can get this posted in time before 3 o'clock that you'll be responsible for it. Consider, where should I flip back to find this topic? Okay, yeah, there it is. All right, consider this. Attempting here to move on a bit. Suppose I know that the sine of some mystery angle, and I'm not going to care what the angle is, happens to be square root of 5 over 5. Square root of 5 over 5. And suppose that the cosine of this same mystery angle happens to be 2 square root of 5 over 5. We're looking for the remaining trig functions. Actually, this is pretty simple, because we know from the previous video, from the identities, from the quotient identities, identity number 3 on page 378, we know that sine over cosine is special. Sine of theta over cosine of theta happens to equal tangent of theta every time. So to find tangent of my mystery angle, whose value I don't care about, to find the tangent of theta, I simply put sine over cosine. I put square root of 5 over 5 over 2 square root of 5 over 5. But you know how to divide with fractions. We will change that to square root of 5 over 5 times its reciprocal, 5 over 2 square root of 5. And then some nice things happen. The 5's cancel. Bang, bang. The square root of 5's cancel. we're left with nothing but 1 over 2. So we know the tangent is 1/2. From there, there's nothing to this because the other three functions are just reciprocals of these. Cosecant will be 5 over square root of 5, but then multiply by square root of 5 over square root of 5, we end up with 5 square root of 5 over 5. Oh, but then the 5's cancel, so that'll just be square root of 5. Of course, I should have seen that to begin with. Secant will be the reciprocal of cosine. Just flip that, multiply by square root of 5 over square root of 5. Cotangent will be the reciprocal of this, which is simply going to be 2. So I'm not even going to bother doing the reciprocal functions. Once you have the first three, you're settled. It's over. Let's apply that to one of the exercises on page 384 that we have not gotten to yet. Let's apply that to number 35. This is number 35 on page 384. And it says the sine of theta is -3/5. And it tells us the cosine of that same theta is 4/5. All right, for tangent of theta, all I do is put sine over cosine. -3/5 over 4/5. Of course, you know your arithmetic. That's -3/5 times 5/4. And that, of course, is simply -3/4. And we're done. So that's your tangent. The reciprocal sine, cosecant of your theta must be -5/3. Cosine reciprocal is secant. The secant of theta will be 5/4. And the reciprocal tangent being cotangent of theta will be -4/3. And we found all 6 functions based on the first 2. Pretty easy stuff, right? So your assignment then, due by, assuming I get this posted by 3 o'clock, I think I will, it's only 1:16, but these things take forever to upload to YouTube. But the assignment will be on page 384. Let's simply play around with numbers. Let's do 30, because this is short. Let's do 35 through, those others were easy too. We're going to be flying through this, but in small pieces. 35 through, oh, these are all too easy, but good practice. Let's do 35 through 42 all. So, page 384, numbers, what did I say? Numbers 35 through 42 all, 35 through 42 all. Of course, you can check your odds in the back of the book. Check the odds. I'm going to start assigning more odds. In fact, I might switch over to assigning nothing but odds, so you can check yourself since you don't have me to talk to. I just might do that and just expect you to use the odd number answers in an intelligent way, not in a stupid way. So that's your assignment, due by noon on Friday, if I manage to get this posted by 3 today. If this ends up being posted later, well after 3 or tomorrow, then this would not be due until noon the next day. Alright, that's the usual procedure. If I post something before 3 o'clock, it's normally due the next day by noon. If I post it after 3 o'clock, yeah, I know I didn't follow that rule yesterday, but if I post it after 3 o'clock, then it should be due by noon the next day. Alright? Alright, thank you, and that's it for today. Goodbye.